Alright guys, this is a quick tutorial on how to use Google Sheets to get your data organized and graphed out and to get a good equation. I know most of you could do most of this on your graphing calculators, but this is how we're going to be using our spreadsheets to do this. Kind of a universal skill. Typically businesses will be using Excel. Since you guys have Chromebooks, we're going to be using the Google Sheets. So we had just completed our first lab. I'm going to try to treat this pretty generically so you can use this again for another lab. It's always a good idea to title your spreadsheet whatever investigate you did, so I'm just going to call this Lab A as a generic title. For this first lab, yours will be the ball bounce lab. And what we need to do is input our data first. So to do that, we're going to first title off what our two variables were. In this case, we had our independent variable, and you would put your units in this heading as well. You also have a dependent variable. You should also put your units in for that. In this first example, you should be having your independent variable as the drop height, and as the dependent variable you would have the bounce height for the ball. Then you can go ahead and enter in your data. I'm just going to make up some numbers here. So let's say this was the data we had collected. The dependent variable that I just entered would have been the average of the trials that we did in the lab. So your next step, after you have that entered, is to get in a graph form. So the way we're going to do that is we will highlight all of the data we want to be in our graph. Then you can either come over here to the Insert Chart icon, or you can go to the Insert Chart option. It's gonna by default put up a bar graph, and we don't want that. We want a scatter plot because we want this to be plotting our points. So we're gonna scroll down under chart type to scatter, and if you notice, it doesn't actually graph it right. So if you look at the x-axis here, it has 5, 10, 15, 20, 30, and 60 all at equal intervals apart, and we know that's not actually the case. So what we will do is go to the Customize tab, click the down arrow on horizontal axes, and we will then unclick this button that says Treat Labels as Text. I really don't know why they put that in there. It's really annoying. That should not be a default when you're trying to graph something. So you have to unclick that, and then we get a better looking graph, and we see all of our values here. We will also always want to make sure that we can see the origin. So I would always force your minimum to be 0. Now I can actually see the 0, 0 point on my graph. Okay. So awesome, we got our data aligned. It looks more like what the graph we would expect to see. So you can also retitle something if you want to. You can click on the graph. I might call this Lab A Data or Lab A Relationships, whatever you want to call it. Obviously you'll have one depending on the lab you're doing. Notice your dependent variable is on the y-axis, your independent is on the x, just like we wanted. We know that our next step is to insert a best fit line to the data and then to get an equation from it. So I'm actually going to go down here to Series on the Customize tab, and I want to click the trend line box. That's going to pull up some options. This trend line to me does look linear based on the data I collected. In this case I made up. If it doesn't, there are other options, but we'll talk about that later. So now it gives me a best fit line, and I also want to see the equation for the line, so I'm going to click on this button right down here that says Label, and I want to click Use Equation. Then you can see it pops up with an equation right here in your little legend box or key box, whatever you want to call that. And that's pretty much all we need from this chart editor menu, so we can close out of that. My suggestion would be to rewrite this equation to the right in your spreadsheet, just so you can access it a little easier, because it doesn't show it in that y equals format. So we're going to type it out. This one is y equals 0.486 x plus, actually minus 0.0294. Okay, so there's my equation. Today in class, you should have learned about how to convert this equation to something that is more useful for that test that you actually set up. So usually you're going to give your y and x values some symbols based on what those variables actually are. So I'm going to use the symbols that our y variable is d for dependent, our x variable is I for independent, and then we're also going to use some units in that equation. So this is how I would type this out if I was putting it in for an actual physical relationship. We know y is the dependent variable, so I would say d equals, and then our slope 0.486, and then we would have the y units divided by x units, x variable, which is I in this case. Obviously, if your x variable was something like time, you would put t. We're going to subtract 0.0294, and our unit would be the our y unit for that y-intercept. So it looks like, if I scroll over there a little bit, an equation that's a little bit more useful. We know that our y stands for the dependent variable. Again, that could be any symbol based on what you actually tested. So for drop height and bounce height, you would maybe want to use D and B. It depends on how you're going to see that there. All right, if you have any questions, let me know.